Könnt ihr mich hören? Ja, super. Okay, ja, you can write code faster, can you deliver it faster? Also heute, es geht nicht um Build Tools, ja, es geht um Software Delivery Excellence, aber ich werde einen großen Bogen machen. Es wird eine interessante Reise werden, was es bedeutet, wie man drauf schauen muss in the age of AI. And I think I better switch to English. I'm sorry. Talk too much German today. So for us, the most important question in the coming years when it comes to AI is not how much more code you can produce, but how much more working software you can actually deliver to your customers. At first you might respond, isn't that basically the same thing? A fair question, but my clear answer is no, and this isn't just opinion. So the first DORA report, I don't know who of you have read it, on Gen AI shows something striking. More than 1/3 of respondents said productivity has increased by 25 to 35%. Right? That is a number. So before I heard 10 to 20% when we talk with our customers, larger customers, that's a number they're seeing for the teams that had good adoption of Gen AI. So great. But, and that is very interesting, delivery throughput, what actually reaches the customers, goes down about 1.5% for every 25% of AI adoption. And stability is hit even harder, a 7% drop for every 25% increase. So developers feel faster, but organizations are often delivering less value. And that's the situation we need to talk about. Because as AI now moves from, hey, this is something we have to do this year and next year, definitely all the focus will be, can we harvest the benefits and the results? And that is one of the main things that is in the way. So before we dive deeper into why this is happening and what we can do about it, I want to step back, right? So as I said, the whole industry is making a massive bet on Gen AI, right? And understandably so, but right now, we're likely investing more than we're getting out, right? It's an investment into the future, right? Especially once you consider opportunity cost. But that may change. We expect a big payback to come, but if it doesn't, it will be quite a disaster, considering the huge investments, right? Every customer we're working with, right, is making into Gen AI. So to make this bet pay off, we need to understand the impact of AI on the entire software development lifecycle, not just on how it makes developers more productive. And that depends on having a clear view on the foreseeable capability boundaries of AI in software. So the question is, are the delivery risks we're already seeing part of a fundamental boundary, something that requires a solid strategy if we don't want to risk our investment? Or are they just growing pains, right? Those problems will go away if AI evolves, right? And AI will solve them itself soon. So now I make quite a detour that I hope you will enjoy as much as I do. So to show why understanding those boundaries matters, I want to take you in a completely different field, biology, and in particular, cancer research. Right? We're moving from speculation to system-level understanding, change everything. And from there, we will go back to SDLC and continuous delivery and what we have to do. So for most of the time, cancer was largely a mystery. Right? We could catalog cases, but not explain them. And only since the beginning of the millennium, we have a complete system-level understanding of cancer as a malfunction at the molecular scale, right? It's driven by DNA mutations, and once you look at the system's dimensions, cancer stops being a mystery. So the body has 30 trillion cells. About 10 million are replaced every second. And for every cell division, 3 billion DNA base pairs are copied. So the initial DNA copy, right, of every single cell division introduces on average 60,000 mutations. Right? That happens 10 million times a second. And the cell has a unit test mechanism called proofreading that reduces this to about 600. Then a functional test mechanism called mismatch repair cuts that down further from 600 to just 1 mutation on average. Well, that's still 10 million mutations per second, right? And most mutations fall into non-coding regions of the genome. So only about 100,000 are function altering, and of those, only around 1,000 affect cancer-relevant genes. And because only long-lived cells really matter for cancer risk, this narrows down further to about 1 cancer-relevant mutation per second. So these are rough order of magnitude numbers, but that's how we can look at this. So that's still a lot. And still too many. So which is why the body has evolved a deep layered defense against mutated cells. So cells can detect their own DNA damage, and they can enter what is called senescence, a state where they stop dividing. Right? They say, I don't replicate anymore. Or they can trigger apoptosis, a programmed self-destruct mechanism. They can basically say, I destroy myself, right? That is for the good of the body. In addition, the immune system is remarkably effective at eliminating mutated cells. But some cancer mutations still slip through, and for a cell to become cancerous, it needs to accumulate several cancer-relevant mutations, typically on the order of 5 or more. Okay, and that is why cancer is a function of age, right? Mutations accumulate over time, and for this, along with other biological reasons, right, cancer risk rises exponentially with age. And that's where we soon come back to GenAI. Cancer is an unavoidable consequence of how the human body works. Nothing we can do about it from the fundamental forces, right? And it's not just humans, right? Any animal with a sufficient lifespan, some more prone than others, develop cancer. So this is a 77 million year old bone from a Centrosaurus apertus that shows clear evidence of bone cancer. And the dinosaur, for the record, self-reported as non-smoker, non-drinker, and not a consumer of highly processed food. So, having said this, mutations don't just come from cell replication. They can also come from environmental agents or conditions inside the body that damage DNA or weaken repair. So that is why the environment plays an important role. It is estimated that 45 to 60% of cancers are avoidable with better lifestyles and environments. That's a big number, but it also means, right, that a cancer floor of 40 to 55% is unavoidable. And remember, people who improve their lifestyle and avoid the preventable cancers will still have the usual likelihood of encountering the unavoidable ones. So, okay. So, without a foundational understanding of cancer, it's easy to believe maybe it could all go away. Maybe it's just lifestyle. Maybe if we all lived perfectly healthy, cancer would vanish and we could stop researching cures. Crucially, this foundational understanding does not just forces us to see an uncomfortable truth, it also shows the path to solutions. More on that later. So, it's a fun exercise to map the cellular processes of the human body into software terms. So 30 trillion repositories, 10 billion builds per second, 4.6 trillion integration tests per second, and 30 quintillion, I didn't know the number before I did that, unit tests per second. So, and for those who just walked in late, this is not a presentation about a new Google build system. Okay, large language models are, like the human body, also massive generative systems that will inherently produce failures. The most famous ones are called hallucinations. I think that's the wrong word. It makes them sound mysterious, as if we don't know why they happen, and pathological, like a disease that might one day be cured. That's misleading. These aren't hallucinations, they're mispredictions. And just like DNA replication errors, they are an unavoidable property of the system. So there is a really good paper, recent OpenAI paper, that gives a learning theory treatment of hallucinations. Right? So it shows hallucinations aren't mysterious bugs, they're the natural outcome of how these models are trained and evaluated. So a key focus of the paper is finding better boundaries between overconfidence and saying, I don't know, right? This is like the immune system. If it's too aggressive, it attacks healthy cells. If it's too permissive, too many mutations slip through. So for our purpose today, the critical insight is this: unless the model is useless and always answers, I don't know, even under idealized conditions, there are lower bounds on error. And in open-ended language tasks, those errors are significant enough that we must treat them as a permanent force. Something to design around, not wish away. And how could it be different, right? The training corpus for the large language models does not contain all the human knowledge about the universe. And then it's a sample, and like any complex sample, it's incomplete and contains errors. But one of the fundamental things that are always worth remembering, the model isn't trained to replicate the corpus, to deterministically reproduce facts. It learns to approximate the probability distribution of the sample data. Right? That's how they work. So when it generates text to answer a question about the universe, it relies on a probability distribution from the sample for an answer, which will lead to mispredictions or withholding a guess. Again, it's a property of the system. So AI coding assistants are already delivering super high productivity. Developers generate much more code, much faster, more pull requests, larger batches. We'll talk about that, right? So here's the first catch, right? Every unit of code carries a non-negligible misprediction rate. So when throughput goes up, the absolute number of defects and regressions goes up as well. It's like cranking up the replication rate in biology. You get more cells, but also more mutations. The immune system is crucial for controlling mutated cells, and our SDLC pipeline plays a similar role for software. So, unless we strengthen our SDLC, the system destabilizes. And that's what we're already seeing, and both throughput and stability go down. Right? As I mentioned at the beginning, that's what the first DORA findings are already confirming. So, I want to return for a second to the cancer analogy. With a deep molecular level understanding, we can see not only why cancer is unavoidable, but also why the body, why the body alone can't cure it, and why traditional treatments so often fail. Right? We now understand how tumors evade immune defenses and overwhelm both the immune system and classical treatments through their explosive cellular diversity. Those are the three forces of cancer. But here's the breakthrough. By understanding the forces of cancer, and that is only really recent that we do that, we've also mapped the vulnerabilities we can exploit. So for the first time, we have a clear set of specific capabilities that can either cure cancer or prevent it from killing. Right? So now, for example, if we construct a reliable marker for the specifics of a cancer cell, meet a couple of other conditions, we can send in the cavalry. Right? We have now the tools. It's game over. It's often not easy, but it's predictable. And so much is happening in this area because we understand the forces and can build our defense against those forces. So And that is really, really important, right? No more searching for miracle cures. We know what to do. It's highly unlikely that any new capability will be added to the toolkit in the next 10 to 20 years. And that's fine because we literally cracked the code. What we have is enough to drive dramatic improvements. And some of the current implementations of this toolkit have already been revolutionary, right, for major blood cancers, for example, and we're still at the beginning. So now it's about the hard, relentless work and investment of implementing medicine along these 5 capabilities for every relevant cancer type. So, is that the end of the story? Not necessarily, right? In nature, there are different strategies for addressing cancer, right? So, take elephants. They have roughly 100 times more cell than humans, yet live just as long. If they had our mutation escape rate, they would have gone extinct long ago, right? They would not reach their first birthday in average. Yet, in reality, their cancer rate is lower than ours, right? Blue whales, same interesting question, right? So what they did is they evolved an ultra-cell-sensitive defense against mutated cells. So when DNA damage is detected, they don't try to repair, they just kill the cell immediately. Super low sensitivity. So could humanity one day edit our genome to build in elephant-like tumor suppression mechanisms without major side effects? Well, maybe. Not in the next 20 years, maybe in 50. It would fundamentally change the forces of cancer. Then we would be a completely different game, right? Removing the assumption that a high baseline of mutations is unavoidable. And it would make today modern cancer toolkit obsolete, but for now it remains science fiction, right? And I don't want to bet my money on that. I want to bet the money on the existing toolkit where they know what to do, and they now just have to put the work in, right, to create the results. So for the coming decades, the reality is 40 to 50% lifetime risk of cancer, right? What we do have is a predictable path to more and more successful treatment. My mom had it twice and survived. She's 87 today. So what we want are more outcomes like that, right? So switching back. So who can see how AI has changed the continuous delivery loop? No one? Exactly. Generative AI is transforming the work inside every phase of continuous delivery, but the stages themselves, the conceptual framework, remains unchanged. So why isn't the framework itself changing, right? Because the folks from Dora are too lazy to make an update? No, the real reason is the fundamental forces of software engineering haven't changed with Gen AI, right? So what are these forces? Mistakes are inevitable, side effects are unavoidable, code must be built, deployed, supply chains are vulnerable, and change is constant. Nothing of that changes with Gen AI. Well, something changes, I will talk about that in a second. So, but in any case, so the forces remain the same, and what is our equivalent to the modern cancer toolkit, right? Those are the continuous delivery capabilities. That's our modern toolkit, right, to deal with the forces of software development. And they have been shaped around that. We know that they work. So those capabilities are more important than ever. Okay, I should have shown them, but you probably know. So that's our attack vector that we need to build up, and I will talk much more about that soon. So why are they more important than ever? Because with AI, the magnitude of the forces is increasing. More mistakes, more side effects, more sophisticated supply chain attacks. We have seen it this year already with, for example, the NX build system attack. All while the pressure to ship faster keeps rising. So fortunately, AI also gives us the means to strengthen every single continuous delivery capability to deal with this force increase, but only if we make that strengthening a priority. So, as usual, when you go into the details, things are not that simple, right? Let's take mistakes, errors, right? So when I say more mistakes, right, we get more mistakes with Gen AI, I do expect AI to make dramatically fewer mistakes per unit of code than it does today. It has to, otherwise it won't be the revolution we are envisioning, right? But if they do less mistakes, that will allow you to ship more units of code over time. So let the AI also do more complex coding tasks, right, when it does less mistakes. So one thing that we're seeing, that the delivery velocity in the age of AI will be heavily determined by your mean time to repair capability, right? I'm not sure whether you are seeing this. What we are seeing is that the bottleneck is shifting more towards troubleshooting, right? Code is produced faster, but troubleshooting is much more complex, right? Because you haven't written the code in the same way. The code is often, the change set is often bigger. So that will be a key boundary. You have to think about what you're doing about this. Otherwise, the value you're creating will not reach your customers, right? So, but in a productive scenario, right, getting more mistakes is part of a virtuous circle, right? Gen AI is generating more code, more mistakes. If you can process them fast enough, right, and fix them, then you're good, right? You need to see more mistakes. It will be, otherwise you're producing less code, right? So I want to provide one more example that I found fascinating, right? So a common narrative I hear a lot these days is production code will soon be a black box created by AI that humans no longer need to understand. And the story goes that tests will be our only interface with the code base. Right? So anyone has ever thought about that? So I found it quite interesting. I heard that from major, I would say, engineering leaders or engineering leaders from major organizations. So what I did then was asking Martin Odersky, the creator of Scala and a computer science professor, he's an advisor of Gradle, what he thinks. And it really helps to ask people smarter than you. So Martin dissected the problem in the following way. He said, there will be code problems. We just talked about it. Right? So tests don't tell you how to debug. If you don't understand your code, how do you debug it? Your hope is to ask the LLM to fix this bug, right? But if that fails, what's your fallback? Without understanding, you have none, except junk everything and start from scratch, right? Which is definitely not a successful strategy for enterprise software stacks, right? So the point I'm trying to make here is, at the moment, because of the excitement and the immaturity in our collective thinking, we are often imagining elephant genes in human DNA, right? Wild shortcuts to avoid the fundamentals. But the key thing we need to do, step back, apply first principles, and look at the forces of software engineering. Then the conclusion is clear. Code must be maintainable by humans, and troubleshooting must be efficient, right? Both important continuous delivery capabilities, right? But it's fascinating for me to see, right, the wild ideas people have in important decision maker positions about what Gen AI might bring, right? And if you think that is the case, you will go on a completely different trajectory with your company than when you think differently, right? So, and now I want to dive a little bit deeper into software delivery excellence in the age of AI, right? So AI accelerates how we create code, but as said, it also amplifies everything inefficient in our delivery process, slow pipelines, long feedback loops, poor observability. So to achieve excellence in the age of AI, we must return to the first principle of continuous delivery itself. What is the most important principle of continuous delivery? That, good, thanks for one answer. And it's not, but I would say small batches are the first principle of continuous delivery. So everything else we do, automation, testing, deployment, observability, exists to make small batches possible and safe. Because when batch size grows, everything else slows down. Integration, feedback, even learning, right? So, and that is one of the key discoveries of the DORA reports. With AI, average batch sizes are actually increasing, not decreasing, which means we're moving in the wrong direction for delivery performance. So, why are small batches so important? They affect everything that matters when it comes to delivering software. Deployment frequency, lead time for changes, change failure rate, and mean time to restore. Right? They're the most important metric, right? When it comes to the most important principle when it comes to shipping software effectively. So, and now we live in a world where they're getting bigger, and it's not like we had great batch sizes before, right? So, and continuous delivery is the art of making small batches fast, safe, and repeatable, right? It's not about automation alone, it's the art of achieving exactly that, right? Okay, so there are two typical pipeline designs that form the foundation for working in small batches. The first is trunk-based development. Who of you is practicing trunk-based development? Yeah, it will become, hopefully, the next slide, I see more hands, otherwise, would be surprised. So, trunk-based development, where developers integrate directly and frequently into main. So, originally, the DORA researchers classified trunk-based development as a key capability. Today, they view it as one possible implementation, right? One powerful way to enable small batches, but not the only one. So, who is practicing this model? Who is practicing none of the two? Please come up front. I want to have a discussion. Okay. The seats are too comfortable. So, yeah, the other common pipeline design is short-lived feature branches. So this model adds a pull request stage between local feedback and merge. It allows for peer review. It's often important for compliance. Large banks need to have that, right? Additional validation. But the critical word is short-lived. Okay. So, however you design your pipeline, trunk-based or short-lived branches, the real question is, what qualities must the pipeline expose to enable small batches? That's what counts, right? So, so now my question is, what pipeline behavior increases batch size? How long-lived the feature branches are? Yeah, I would say that's a consequence of certain pipeline behavior. So what else? What do you think as a developer? Come on. In Berlin, I get an answer for this in 1 minute. I'm kidding. But, pardon? Exactly, feedback cycle time. Great, we have 1 out of 4. Yeah, which is kind of, you could say maybe the reliability that increases flakiness and stuff like that. So kind of pipeline reliability. And I would say the degree of automation to make it smooth, yes. Determinism, 100%, that goes into flakiness, very good. In what sense? The feedback cycle time, 100%. What's happening here? So feedback time, we talked about it. Pipeline stability, we talked about determinism, right? Then troubleshooting time. So when it's extremely painful, right, to find out why something is wrong. Is it the CI environment? Is it the other binary repository manager? Is it my code, right? Then you're like, oh my God, when I have to go through this with every pull request, right? Maybe I don't do this 5 times a day. I only want to do this once a week, right? And then finally, very important, low test coverage. If you don't have trust in your tests, right, I would be very reluctant, right, to ship frequently because it means there will be trouble at the end. I want to avoid that, to have that too often, right? So that is in my experience. Those are the 4 key things that lead to behavior of developers to have larger batch sizes. And then you could also say bad development culture, right? But even if you have a good culture, all those things will lead to larger batch sizes. Okay. So how do we have to work this, right? So for each stage, you balance different trade-offs, right? So the local stage prioritizes fast feedback over completeness, while the merge stage emphasizes thoroughness. But speed alone isn't enough, right? The key thing, each stage must still catch most of the failures before they move downstream. I'll give you an example. Large software company, market cap several $100 billion, their flagship product. A large Maven monorepo build took about 25 minutes to run locally. Developers were complaining about it. They said, hey, we want faster feedback, right? We cannot work like this. So they said, okay, let's try to fix this. And they got it down to 22 minutes. Not good enough. And then they had a magic idea how to fix this. They said, it needs to be faster, right? The continuous delivery book says a couple of minutes. So they said, hey, developers, for the local feedback loop, we have this great idea. Just stop running your tests. And boom, faster than 5 minutes. And they told that straight to my face. There's no creative freedom here. I applied to that story. They said, hey, we fixed the problem. Right? I said, okay. But if you look at this from this model, well, you now have a local feedback loop, okay, that is fast, but the key job is catch most of the bugs. It's no longer serving that purpose, so it's kind of pointless, right? It's now, hey, we're playing continuous delivery because someone told us, right, we need to pretend that we do continuous delivery. That's the very opposite, right? They shifted everything to the right, and so when we talk about, the trade-off, right, the key thing is we need to make things fast, but still catch most of the failures, more of the failures than are caught by the later stage, right? So that's but it's not easy. How do you make that 22-minute Maven build? How do you get this under 5 minutes and still preserve the feedback quality, right? It's not like the problem I had with them was not that they were not able to solve the problem, but that they were thinking it was a good solution. So let's step back, right, before we talk about solutions, right? The most important thing now in the age of AI, we should have done that 10 years ago, but now is the time. We need to change how we think about our delivery pipelines. Most organizations, and I work with so many organizations, right, from the Bay Area giants to the largest banks, to many smaller companies, right? Most organizations still treat CI/CD as internal plumbing, right? And the DevOps people that are treating CI, they don't understand developer pains. They just provide CI as a service, right? But our toolchain is a production system, the production environment for creating software. So every commit, test, and deployment passes through it. And when it slows down or becomes flaky, so does innovation, right? So, and with AI, these weaknesses become exponentially worse, right? That's why we must operate our tool chains with the same rigor as production. And most companies are not doing that yet, right? SLA level reliability, observability, incident management, and ownership. Give you an idea. If I would ask you, hey, what annotation processor is how much time of the feedback cycle is spent on annotation processors for Android for the team in Singapore? You probably would look at me and say, interesting question. I have no idea, right? If I would ask you, how much is the dependency download time for NPM different for the team in Sydney versus the team in Hamburg? You would say, I don't know, no one is complaining, so it seems to be okay. That is the answer, right? That is our level usually. No one is complaining, it means things are okay. Only if people are complaining, we need to do something about it. That's not, hopefully, how you treat your production system, right? When a shopping cart doesn't show to your customer and no one is complaining because they go to a competitor, right? You hopefully don't think you're in a good state. But that's where we are with our pipelines, right? Hardly any observability and no no rigor, right, in creating the capabilities that we need, right? What are those capabilities, right? For me, 4 core capabilities, right? Most important one is telemetry for builds, test, and environment for local and CI. How can you reason about problems when you don't have data? I mean, you shouldn't even start, right? So, and what I still see in most organizations when it comes to prioritization of improvements in the SDLC, it's basically who screams the loudest, who escalates the hardest to, and then they get priority, even if it's not the most important problem, but there is no data, right? So people cannot make decisions, right? We're not able to make data-driven decisions when it comes to the SDLC, and the SDLC is complex, right? If you don't have data, you just cannot prioritize, and that means you're leaving a lot of potential on the floor, right? So that's number one, and then accelerate, 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 right? So caching, caching, caching. Caching build output, caching dependency downloads, caching build configuration. There's so much we can do, especially with most people. Who of you is practicing ephemeral CI? So basically where CI always throws away the state before it runs the next build. I mean, everyone who's in GitHub Actions does it. Okay. But it's a huge performance impact. When organizations introduced that, feedback cycle time got worse by a factor of 10. Right, and so there's so much we have to do to make ephemeral CI more efficient. And then troubleshooting. I already talked about that. It is a new bottleneck, right? We see this over and over that with AI-generated code, right? This is a big problem, and it starts with the very simple problem we see at every reasonable large organization. There's a CI failure. And first there is finger pointing, who is responsible for looking at it? Hey, CI team, it's the environment. And then the CI team says, no, it's your code, failing tests, is the reason, right? So they don't even know who should look into this, right? Let alone then fix it, right? So that is a huge opportunity, I think, for using the power of AI for failure classification and clear assigning of responsibilities and finding out the root cause, et cetera, et cetera. So much data in the system, right? Organizations running thousands, 100,000, millions of builds a day, right? And when you use that data, you can reason so well about what is the root cause of a certain problem. But most organizations not doing that yet. And then governance, risk, and compliance, right? How do you automate that? How you shift this left, right? So again, to come to a conclusion, right? The first reports on AI's impact on software delivery metrics are a clear warning. AI doesn't fix weak delivery systems, it exposes them. And that is not going to change over the next 20, 30 years, right? We talked about the fundamental boundaries of AI. And if your pipeline can't keep up now, AI will make that painfully visible. And the reality is that our pipelines have orders of magnitude of untapped potential. Orders of magnitude make them faster, orders of magnitude to make them more reliable, and we must close that gap before AI widens it further. So for that, right, we need production-grade tool chains, observable, fast, reliable, and compliant. And that's the opportunity and that's the responsibility for everyone, right? Otherwise, I guarantee you the big harvest of AI in terms of shipping more values to your customers is not going to happen. Thank you.